So yeah, then maybe let's get started. Let's see when the rest's gonna. Yeah, hi. So I hope you're not too tired yet. I try to walk you briefly through like how we did Kubernetes on AWS at Zalando. I'm Michael. I'm with Zalando now for roughly 1.5 years. Joined them first on the German office in Dortmund and moved to Helsinki beginning of the year. I'm working as a engineering lead at Zalando, leading a team of people working with like external integrations into the Zalando platform. And yeah, I'm a Java developer by heart, so always try to still get my hands dirty a little bit. And I've been always interested in doing some DevOps stuff. So yeah, I don't know how many of you know Zalando. Who has ordered at Zalando? Ah, good. Yeah, so we're Europe's leading fashion e-commerce platform, currently active in 50 markets. Well, kind of 21 million active customers, and then making quite some revenue, like having over 13,000 employees now. And when it comes down to like a little bit more tech stuff, so we currently have like over 1,800 employees working in like tech-related jobs, software engineers, UX designers, and the like. We have offices in Berlin, tech hubs in Dublin, Helsinki, and Dortmund. We have over 100 different nations working here. I think the Helsinki office has by now 28 different nations working here. And yeah, as you might know, we're kind of looking to hire people. So just in case you're interested, and well, reach out. Go to tech.zalando.com. There's quite some positions open. Yeah, maybe talking briefly about how we ended up considering Kubernetes and then how our journey was. So, well, in the beginning, we started with PHP. Then in 2010, when we aired our first TV commercial, we realized that the PHP solution did not scale, so we moved over to building our Java monolith based on Tomcat. This one's running in the data center. Built some custom tooling and the like, and then in 2015, when we kind of started that rapid scaling of the engineering teams, we moved over to building stuff based on microservices. Are currently in the process of moving away from the data centers, deploying all stuff on AWS. With the microservices, we moved already over to running Dockerized applications. So whatever we deploy on AWS is a Docker container. We use CloudFormation to spin up the stuff there. We do immutable deployments on AWS as well. And yeah, end of last year, we started shifting over to Kubernetes and then like kind of considering Kubernetes as the deployment infrastructure, again, on AWS, Docker as well. So that part was pretty easy moving forward. So when we talk about large scale at Zalando, I'm not going to talk about like running Kubernetes clusters with thousands of nodes. Large scale for us means like addressing those 1,800 different developers on like over 200 teams and the like, and how to get this done. So large scale for us means currently every of our engineering teams has at least one AWS account, which is currently like, I think it's even above the 255 active AWS accounts. So that's like kind of the scale we're operating in. And that's what we need to address on Kubernetes as well, like kind of find a solution on how to scale those infrastructure stuff. So as I said, like kind of we have like roughly 200 engineering teams. We're aiming for a final solution about having like 30 different clusters. This stubs infrastructure is how we currently deploy stuff on AWS. So this is some tooling built around manifest like CloudFormation stuff and ensuring that people like that we can somehow have CloudTrail stuff when we deploy to AWS and the like. And yeah, as I said, like we already have like Dockerized applications. So one of the main goals was to have no manual operations for those Kubernetes clusters, just to make sure that we can actually run 30 of them in production. They obviously should be reliable because, well, if it goes down, we're going to lose money there. And when we're talking about 200 teams, they should be auto-scaling. So we don't want to have like DevOps teams scaling up and down clusters. And like migration should be seamless. But based on the Dockerized apps, that's quite easy to achieve. So if we're talking about different Kubernetes clusters, they really gotta live totally separated. So there is no like VPC peering, no overlay stuff between those clusters. So no magic on a network level to make them work. They all talk through public internet and are authenticated using OAuth2 credentials. That's stuff how we currently do it in our infrastructure as well. So we just needed to make sure that this also works on Kubernetes. And I'm gonna come back to that a little bit later. So how our development team should interact with Kubernetes is pretty straightforward. We do not want to give them write access to production clusters, at least not for normal operations. So normal operations is you develop your code, you push it to GitHub Enterprise. This one triggers an automatic build and goes through our CI/CD pipeline. And this is the only way to get code deployed on production clusters. For obvious reasons, there is some emergency access. So in case like we have some live issues, you might want to look into the pods, but this should not be a normal operation. And on the clusters, we have our master nodes and the worker nodes, and those are basically based on autoscaling groups. I think this part is quite straightforward, and we already saw this. So how does deployment work? Well, the part on top is straightforward Kubernetes manifests, the deployment for Kubernetes, building some credential stuff, defining ingress, defining service stuff, and the delivery YAML is basically a pipeline description of the steps that need to be done to get the stuff from checking out the source code to deploying it on the cluster and switching traffic to active steps. So this is like proprietary configuration for the CI/CD pipeline. That's a standard ingress YAML. Kubernetes straightforward. You just define your host and which path and to which application or to which service this should map, and then, well, Kubernetes does the magic, as we've seen in the first presentation. This is currently our deployment or continuous delivery platform that has different steps where you can like kind of build the stuff first and then maybe deploy it to a staging cluster, deploy it to a production cluster. What we have in there is, for obvious reasons, you get like kind of output on what works, like standard build server stuff. We try to use like existing solutions for that part. So we started off with a Jenkins-based solution, which did not work out in terms of like addressing the requirements we had from making sure that we can have correct audit trails, that it scales with the clusters and the like. So that's when we decided to build our own continuous delivery platform tailored to our needs, and then making sure that it adheres to whatever we want to have there. For example, it has stuff like deploying stuff to production would need like manual approvement, so someone will need to click the approve button. Now let's go to production. That's more or less kind of configurable on your deployment stuff. So for specific services, we want to have like real continuous deployment, getting it to production. But for like stuff that is not yet ready for continuous deployment, someone might want to just test the new deployment or make sure that it runs in staging and then enable it on production. So as we're running on AWS, you heard that one of the main ideas for Kubernetes is to be cloud kind of provider agnostic. We realized it's not going to work for us. So our first idea was we go Docker, and then we can switch from AWS to Google and to Azure, and that's going to work like a charm. But in the end, if you be totally cloud or provider agnostic, then you lose all the benefits of that specific platform. So if you do not care about if you're running on AWS or on Google platform, well, there is no DynamoDB, there is no SQS, there is no RDS, because, well, this is provider login. There are no IAM roles, for example. So this is the part where it actually gets like provider specific. And we built this stuff in a way that it fits in totally into the standard Kubernetes deployment stuff. So in here you can like define your custom stuff like a IAM role or an RDS database, and it's just adding like deployment YAML files in there, and the rest is again standard Kubernetes stuff. So for example, in this like specification, this is a template as well, and you can say that, well, this specific containers should have access to a specific AWS IAM role, which means, for example, you can tell one specific pod or service that it has the right to access a private S3 bucket, for example, or that it can access the the DynamoDB database. And all that stuff is taken care of our Kubernetes infrastructure. So the developers do not need to assign like any roles to any nodes on the cluster or stuff. That's happening. All the magic is done when the stuff is deployed. Yeah, as I said, like cluster autoscaling. Well, we want to make sure that the cluster really autoscales. That means it should be able to fulfill all the resource requests that come in. So if on one of our production clusters, a new development or the delivery team decides, well, there is a new service, it should run on that cluster, and the cluster recognizes, well, I don't have enough nodes for that part, it should scale up. We built it in a way that it has at least one spare node per availability zone there, just in case one node dies, failover works faster, and then we can scale out as fast as possible. There is no manual tweaking of any cluster in there, so it's all down to the autoscaling stuff. If we find any issues that it does not work as expected, we change the underlying configuration of the autoscaling and do no manual tweaking of the clusters, just to make sure that we have a common shared configuration for all our 30 production level clusters. Yeah, the part that was more challenging is not actually the scaling up, but the scaling down part. So in the beginning, the first version was quite easy to add new nodes, but those nodes just stayed there. So once you hit a spike, you got up to your maximum number of nodes, and they stayed there, and then that turned out to be quite expensive. So we wanted to make sure that it's really, really elastic, but in a way that it doesn't scale down too fast. So if you just have like a couple of those spikes coming in, you want to make sure that it not needs to scale like the whole way, because like starting a new node and getting it into the cluster takes any time between 2 to 15 minutes, depending on like the standard workload on AWS, and then when it's able to fulfill your request for getting a new instance. Yeah, so far it's been mostly based on existing open source solutions or stuff that we could find out there. For our AIM integration, this is stuff we built custom in-house, beside the delivery platform, which we also built. So our standard idea is that your pod runs a service which needs to access a resource server, maybe a service from a different team on a different cluster. Therefore, it is like public internet, OAuth2, authenticated. So first of all, if it would hit that endpoint, it would get a standard 401 unauthenticated stuff, because it needs to have the OAuth credentials in there. So how we do this is based on what we currently have on our previous architecture as well. So we have some mechanisms in place to share secrets and provision like OAuth credentials to all our different services. This is way easier now with Kubernetes than it was with the existing infrastructure. So for Kubernetes, it's pretty easy. You as a developer just define on a YAML file again, well, this service would like to get credentials for a specific, or would like get OAuth credentials with specific scopes. You put it into the Kubernetes API server. The kubelet queries the server, knows, well, I should provision specific OAuth credentials, and therefore it talks to infrastructure services and then makes sure that it mounts your OAuth2 Bira token in a path on the pod. What does that mean in the end? Well, if you would have a microservice based on Bash, you could run it as simple as that. So you just simply cat on the credentials pass that token secret, and this one can just go into the Bira of the OAuth2 token. You call the other service, and it works, because the other service, again, gets the token, validates it against our OAuth infrastructure, and that's it. So from a developer perspective, you do not need to care about getting an access token, about using your refresh token to get the next access token if it expires, and like that's all handled by Kubernetes. So you just have to like cat the secret. And if you're, for example, running on Node.js, well, it's pretty easy as well. Build a library that always reads from that file, and it's up to date. Yeah, so, well, we hit a couple of challenges on our way there. One of the biggest one was actually how to get started there. For us, how to get started was finding out how we want to run our Kubernetes on AWS. So we did some like survey on what's out there, and then yeah, in the end, decided we're a big company, so we're gonna go with our custom infrastructure there, which is partially based on that we already had tooling for AWS and how to manage cloud formation stacks and how to scale them and how to make sure they operate. So we've already had quite some experience on AWS and thought, well, we can easier learn the part of Kubernetes rather than see that we get the existing Kubernetes stuff to adhere to our requirements when it comes to compliance and the like. So in the end, it's pretty easy. We have a very simple API CRUD service there for the cluster registry. We have some manager that just sees if a new cluster is required or if cluster needs updates. And then in the end, our cluster lifecycle manager talks to the Kubernetes API server and applies the manifest after it actually created the CloudFormation stack for the auto-scaling groups based on our existing tooling. So this part is based on existing tooling, and then we just added the stuff to talk to the Kubernetes API server and say, well, that stuff should be deployed there on the cluster when we spin it up. So this applying of manifests is, for example, mounting of our OAuth2 credentials, making sure that the AWS integration is there and so forth. So our clusters persist of two CloudFormation stacks, one for the master and the worker stuff that auto scale. We obviously use etcd for the Kubernetes stuff. Our nodes run on standard container Linux stuff, and then after we started that part of the cluster, we apply the manifests and deploy whatever we need in there to manage the stuff. Then our goal was really to make sure that we only talk to the Kubernetes API. So the idea was not to talk to the Kubernetes API and talk to AWS APIs and the like. And that's why we started to build an integration for managing our DNS records in Route 53. So this mate was our first attempt, and then we moved over to external DNS, made it a little bit more generic. External DNS is now an official Kubernetes incubator project, so if you want to check it out and contribute there, we're happy to add that part. Our ingress controller for AWS is open source as well, so I think it's one of the two standard projects out there to use AWS ELBs for ingress. And we use the existing kube2im project for the AWS IAM integration. Our ingress stuff, pretty straightforward actually. Our ingress controller talks to the Kubernetes API server, and then based on what ingresses should be defined, it creates the ALBs at AWS, make sure that they get the correct SSL certificates assigned. So based on which host you define on your ingress stuff, sees if there is an existing ALB it can attach itself to. If there is none yet there, then it creates a new one. And internally on the worker nodes, we use our in-house HTTP router skipper to actually route then the requests to the respective services. But that part is totally exchangeable. So if you want to have a different HTTP router on there, well, go for it. We just simply choose our existing solution because we know how to operate that one. So it can do cookie-based routing, it can do header-based routing, it can be path routing, so whatever. We just know how to run this at scale. So that's the main reason why we went for skipper there. There's a couple of questions we asked ourselves when we get started. So do we want to go single availability zone or multiple of them? Well, we choose multiple for failover reasons, and why not? We did not go for cluster federation because we just believe it's not there yet to run at the scale we need it to run. For the overlay network, we go with Flannel because it's rock solid and there and it just works. For authentication and authorization, we rely on our existing OAuth infrastructure. So pretty straightforward. Call this as a webhook from the Kubernetes API server, just because it's been there and it's integrated with any company-wide authorization system. I think if you already have a bigger company and you have single sign-on systems, then most probably you want to integrate those as well. Second challenge is obviously stability versus having the newest features in there. So what we do there when we update our clusters, you as a team can define what branch your cluster wants to live in. So if you're like more on the cutting edge stuff, then you will go for the alpha branch, get in all the newest features as fast as possible, but the potential downside that it might break and it might impact your operations. If you're more like, well, stable, just make sure it really works, we don't need the newest features, then well, you go for the stable branch. And yeah, you can always like, we do this kind of cluster updates and get external stuff in, get the PRs ready to merge and then deploy them and basically move them through the different branches. And only once we know that stuff has been proved to work at our setting on the alpha branch, then we would move it on to the beta branch, and the same for beta over to stable branch. So that's basically making sure that we do not deploy the newest stuff to clusters that are really important for day-to-day operations. And then if those clusters do not need that specific features, then why risk to break them? Yeah, one of the biggest problems we encountered in terms of stability is that we hit the AWS rate limits. We actually did that twice. So we hit that problem with our external DNS or mate stuff and with the ingress controller. And the downside there is if you hit those rate limits, then you basically lock yourself out, because you cannot make any more calls to the AWS APIs, and the cluster just stays in any unpredictable state because, well, some calls might go through and some not. Kubernetes itself has, the core itself causes quite a lot of those requests as well for EBS. That got better in recent versions. And well, we have some monitoring stuff running that also pulls a lot of AWS APIs to get information. So yes, that's one of the biggest pain points we still see with AWS, just making sure that we balance those API requests on a level that they do not impact production code. Well, luckily, if you're on enterprise support and you hit the stuff enough and you pay Amazon enough money, then at some point you kind of get some feedback on how many of API calls you can do. But still, this is, if you plan to go to AWS, keep this in mind. You might eventually hit those rate limits. Yeah. What you definitely want to do is use the limit range on Kubernetes. If you haven't heard about it, just look it up on documentation, just to make sure that specific pods cannot actually kill the rest of your infrastructure by just demanding like whatever resources are available there. So we didn't do this in the beginning, and we had quite some of those deployments who killed the whole cluster. Yeah. Second challenge was how to onboard our developers. As you saw, like we have 200 teams, 1,800 engineers. As you saw in the first presentation, there is a huge amount of new concepts for Kubernetes, and to teach all of our developers with those new concepts, a lot of them maybe not caring too much about the low-level details, but still they should, because they are responsible for running that stuff, also in production. We tried to address this in a way that, well, there is a Kubernetes training internally that basically guides developers through what they need to do to get stuff running on the Kubernetes clusters. We have some documentation, part of it open source, available publicly, part of it internally. That one's definitely a ongoing effort to make it better and better over time. When we started our journey, we did Friday demos where we each and every Friday demoed new stuff we added to our offering there. So started from the very basic stuff of how to get the Kubernetes stuff on, like, well, now this new feature is ready. All those stuff are internally available to still kind of have a look at it and then learn how to do continuous deployment there. And yeah, in the end, there is still support channels. People ask a lot. The more and more teams that get onboarded on Kubernetes, the easier it is, because then you get this peer support. So in the beginning, it's been pretty hard. It's that infrastructure team answering all the support requests. Now a lot of the more experienced teams already help out, like the newcomers there. Yeah. User experience. As you might imagine, those developers, big amount of them, they kind of get demanding on what to expect. So that's what we needed to learn internally as well, see all our platform offers as offers, like products we sell to internal customers, being our developers. So the decision on why we want to develop our own continuous delivery platform versus going with an existing solution like Jenkins or Travis is an ongoing effort to convince users what's the benefits versus the trade-offs. Again, like the different YAML files, and for them making sure that they understand the difference between what is a Kubernetes YAML file, because they already previously used CloudFormation-based YAML files, so just to make sure that they do not mix the concepts there, that this is clear. What we encountered, especially in the beginning, is like having inconsistent states on the clusters. And as we saw that, we do not want to give people write access to production clusters. So resolving those inconsistent states might not be up to the actual developer because they do not have write access to the cluster. So this is like kind of just making sure how we can manage that part. Turned out to be more complex than we initially estimated. Yeah, well, you might ask yourself why not go with the AWS ECS solution and then rather build our own. One of the main reasons was we saw more benefits on building our own solution versus using the existing one, especially when it comes to our integration in like AIM infrastructure and our OAuth infrastructure. This is a project from one of my colleagues at Zalando, from Henning Jacobs, who basically drove most of our Kubernetes efforts, called kubeOps That's just gonna render you like how your cluster looks like. So those are the different, I think those are the two master nodes and those are the worker nodes, and those green and red boxes are pods there. So the green ones are good, the red ones are dying. So you can just have a look, and this is printing the resources on there. It's a pretty cool tool. Just scales up to a specific size of the cluster after. I think it's based on SVG, if I remember correctly. So if it gets too big, then it just crashes your browser. So that's basically it. There's a couple of links to stuff we do or we have there. So we try to have a lot of our documentation for running Kubernetes on AWS in production on GitHub or like read the docs. This is our ingress controller, the external DNS one. This is ongoing effort right now, our Postgres SQL operator, to make sure that we can deploy Postgres high availability clusters on Kubernetes and make sure that they run and scale and survive nodes going down and pods being terminated and the like. I think my colleague Jan is talking at PostgresConf later this year about like how we built that offering and why we believe this is even better than RDS from Amazon, and then what the benefits are there. We share a couple of our cluster configurations on GitHub. And again, Henning just compiled a list of organizations that are using Kubernetes on AWS, just in case you want to check it out. That's basically it. I still need to make sure that I get the permission to actually share those slides afterwards. That's still an ongoing challenge, but I'm pretty sure we're allowed to do so. Otherwise, just search, because those are pretty similar to stuff Henning already gave, so those presentations might already be available. If there's any questions, feel free to ask. Otherwise, I hope it's been somehow interesting for you.
Well, you touched on a lot of points there, but when you moved over to a Kubernetes-based solution, what did you find the hardest?
I think the hardest was convincing our delivery teams to switch to yet another solution. And there is I think we have the two extremes of developers in there. So we have developers who do not really care about any of the operation stuff. So they just, for them, Kubernetes is maybe even too low level, because they just want to write their applications and somehow get them deployed and run them in production. And there are the other extreme of the developers who really would actually really like to have the bare metal access. So for them, even our old infrastructure offering was like abstracting too much. So this is kind of trying to balance that out and what is the right abstraction level, and convincing delivery teams on why this is beneficial for them. Like this whole user experience, onboarding, getting started stuff for the teams and rolling this out really at scale is one of the biggest challenges we're still facing. And we still need to survive our first Black Friday on Kubernetes. So because it's kind of from scalability issues, one of the like biggest challenges we have ahead, making sure that this part of the operation can really scale under heavy workload, and then that we can manage it. And so we're not there yet that we are currently completely on Kubernetes. So I think it's only less than 10% of our services are currently running on Kubernetes. The rest is still either running on a data center or running on our old AWS Stup stack. So currently we're basically running 3 different deployment stacks, which definitely is some challenge in making sure that you still have enough people who know each of the stack and can troubleshoot stuff there and make sure that we get the migration paths right. And yeah.
But your goal is to go all the way Kubernetes.
Let's put it that way. We still believe this is the way to go, if we can prove that it scales under the heavy load we expect on stuff like Black Friday. But we're quite confident that we can get there. Any further questions?
We tried how different cloud providers scale. I mean, like you have a good example of a load and you have a multi-zone data center, so you can easily try it.
So, can you just, like, if you tried it on different...
Have you tried your example workloads on something except the AWS, like on Google Cloud,
so
on Amazon? You have a good experience
okay.
with, like, one of the clusters can be tried to run on somewhere.
Yeah, so the question was whether we tried it to run it on different cloud providers, like, for example, Google. No, we didn't. So, like, our first idea of when we moved to the cloud and to AWS was, well, we want to be able to move to a different provider, but from a pure commercial and business impact assessment, we just decided the effort we would need to put into place to run stuff on Google is just not worth the potential payoffs. So we just learned enough with Amazon, and then we kind of have good enough experience that it just doesn't pay out.
Yeah, I have one. I have this sort of hunch that because Kubernetes abstracts a lot of complexity away from you, that maybe bare metal is coming back a little bit. People might start running it on top of bare metal actually instead of cloud servers. So do you have an opinion on that? Like why use EC2 instances that are super expensive compared to, let's say, if you got some really cheap bare metal and just use Kubernetes to handle all the breaking servers?
Yeah, so the question was whether I have an opinion on
running Kubernetes on bare metal.
Yeah, running Kubernetes on bare metal.
Would be like really cheap,
yeah.
And you could buy like a huge ton of it.
Yeah, so I think for us the reason to stay with AWS is just the potential that it's fast and easy to scale out. For bare metal, we would normally have to buy the hardware because that's when you really get the benefits, and we're still in like kind of the part where we do not really have like. So if you look at Google, they have like a pretty stable workload for most of the stuff, so they know exactly like what they need. I think then the benefit of having your own hardware and your own data centers really kicks in. For us, it's still like we're still growing, so we're still growing in terms of engineers, in traffic, in revenue, and then monthly visits. So it's pretty hard for us to predict what type of hardware would need, and there we still see the benefits of AWS, of the elastic of the cloud.
Have you thought about like the idea of splitting with data? So, for example, like confidential data on-prem and public front ends in Amazon. Yeah.
So the question is whether we thought about splitting data on confidential stuff, maybe on-prem, on the rest on AWS. Yes, we assess that stuff as well. Currently, as far as I know, we're confident enough that we still can have confidential data on AWS to some extent. There is a couple of data potentially when it comes to credit card information, but I'm not sure if we store this at AWS or if we can store it at AWS, but that's like not my part of expertise. Yeah.
I have a quick question on managing state. You mentioned that you use RDS and S3, and on the other hand, you had some incubator project for running Postgres on top of Kubernetes. Are you storing state on your Kubernetes cluster, or is that something that you?
So yeah, the question was whether we store state on our Kubernetes cluster as we like kind of have Postgres stuff and running RDS and S3. For the Postgres stuff, yes, we store state in there. About the details, I unfortunately don't have like the answer. I think going with RDS was just for most of the teams the easiest way, because it's just clicking on the console and it spins up the stuff and you do not have to care about the operations. On the other hand side, RDS is pretty expensive compared to our own database as a service offering, especially on like load. And I think we managed to grow our in-house solution to where it is even more efficient than RDS, so we can really do rolling updates with zero downtime on the Postgres clusters and the like. For S3, we mostly use it for really storing blobs of data most of the time. Good. If that's all, then thanks for your attention.